Turn any PDF into an editable 3-host AI podcast, with custom voices, citations, and a complete Python pipeline. Let's begin with Build an Editable 3-Host Podcast. This project turns a PDF into a conversational audio overview with 3 distinct speakers. Unlike a fixed hosted experience, the script is saved as JSON before any audio is generated. That means you can rewrite a weak explanation, add a third expert, change the tone, or replace one voice without starting again. The pipeline extracts source text, identifies grounded insights, writes a structured conversation, renders each turn, and joins the audio. Our demo uses an API-based language model and text-to-speech provider, but each stage has a clean boundary that can be replaced. The real goal is not to copy a product, it is to understand and control the mechanism behind document-to-podcast generation. With Build an Editable 3-Host Podcast in mind, the next piece is see the whole pipeline first. A PDF enters the system and becomes clean page text with source metadata. Because long documents may exceed a model request, the text is split into bounded chunks. The model extracts evidence-backed insights from each chunk, then combines them into a briefing. A second model call converts that briefing into a typed multi-speaker script. A validation step checks speaker names, turn length, citations, and total episode size before spending money on audio. Text-to-speech renders one WAV file per turn, and the audio mixer inserts pauses and exports the final MP3. Saving every intermediate artifact makes the workflow editable, resumable, and easier to debug. With see the whole pipeline first in mind, the next piece is project setup and folder design. Use Python 3.11 or 3.12, a virtual environment, and FFmpeg for reliable audio conversion. Install the OpenAI SDK, pypdf, pydantic, python.doten, and pydub. Store the API key and model choices in .env, never place credentials in the Python file or screen recording. The input folder contains the source PDF, while work holds extracted text, insights, scripts, and audio segments. The output folder contains only the finished podcast and a human-readable transcript. This separation lets you rerun only the failed or edited stage instead of paying for the entire pipeline again. Once project setup and folder design is clear, configuration makes the generator yours becomes much easier to understand. The configuration defines the source file, episode style, target length, speakers, voices, and model names. We use 3 roles, a curious host, a technical expert, and a practical skeptic. Each role has a speaking purpose, not just a different name, so the conversation avoids repetitive agreement. Voice IDs remain configurable because provider availability can change and different voices suit different languages. The target number of turns controls cost and episode length more predictably than asking for a long podcast. A good configuration is the first advantage over a locked generator. Format choices become data, not hard-coded assumptions. From there, the next practical step is extract text and detect scanned PDFs. pypdf can extract text from PDFs that contain a real text layer. We process pages separately and keep the page number beside every block of text. Page metadata later allows the insight extractor to cite where each claim came from. Empty pages are skipped, but a nearly empty document triggers a clear error instead of producing a hallucinated podcast. Scanned PDFs often contain only images, so normal extraction returns little or no text. In that case, stop and run OCR first. Text extraction and OCR are different problems. The verification step prints page count and character count so you know whether the source was captured successfully. This sets up the next important point, chunk long sources without losing context. Sending an entire document in one request can be expensive, slow, or larger than the chosen model supports. The chunker groups page blocks until a character budget is reached. A small overlap carries the ending of one chunk into the next, reducing broken explanations at boundaries. Every chunk preserves the page range so downstream insights remain traceable. Character-based chunking is intentionally simple for this tutorial. Token-aware chunking is a useful production upgrade. The output is not yet a summary, it is a controlled set of source packets ready for evidence extraction. This sets up the next important point, extract grounded insights in batches. The first language model stage does not write podcast dialogue. It turns each source chunk into a short list of claims, explanations, examples, and page references. Structured output forces each insight into predictable fields that Python can validate. The prompt tells the model to use only supplied text and omit claims it cannot support. Processing chunks independently reduces context pressure and makes retry smaller. We save the combined insight list to JSON, creating an inspectable evidence layer between the PDF and the creative script. If this layer is inaccurate, better voices will only make the mistakes sound more convincing. If this layer is inaccurate, better voices will only make the mistakes sound more convincing. That sets up build the briefing before the dialogue. Raw insights may repeat the same idea across several pages or chunks. The briefing stage merges duplicates, orders concepts, and selects the strongest examples. It also identifies tensions, limitations, and open questions that can create a natural discussion. The output remains factual and compact. Personality is added in the next stage. Separating briefing from dialogue makes the workflow easier to review and reduces unsupported improvisation. A saved markdown briefing gives the creator a fast checkpoint before generating dozens of audio segments. With build the briefing before the dialogue in mind, the next piece is generate a typed multi-speaker script. The script model receives the approved briefing plus explicit definitions for every speaker. It returns an episode title and an ordered list of turns with speaker, text, and supporting page references. The curious host introduces questions, the expert explains mechanisms, and the skeptic tests practical limits. Turn-level word limits keep text-to-speech natural and make later editing easier. The prompt bans fake quotes, invented statistics, and claims outside the briefing. Because the result is validated against a pedantic schema, malformed speaker labels or missing text are caught early. The JSON file is now the source of truth for both transcript and audio. That idea leads directly to edit the script before paying for audio. Open the generated JSON and read it like an editor, not like a developer. Remove repeated compliments, scripted laughter, filler questions, and unnatural handoffs. Check every important claim against its page references and correct any exaggerated wording. Shorten turns that would sound like mini lectures and let speakers react to specific ideas. You can add, delete, or reorder turns as long as the JSON remains valid. Running the validation command after editing catches unknown speakers, empty text, and excessive length. This checkpoint is what makes the generator genuinely controllable rather than a one-click black box. Once edit the script before paying for audio is clear, map speakers to voices safely becomes much easier to understand. A voice map connects each speaker label to a provider voice and delivery instruction. Delivery instructions describe pace, warmth, and emphasis without impersonating a real person. The same script can be rendered with new voices by changing configuration only. Never clone or imitate someone's voice without documented consent and appropriate rights. Tell listeners that the voices are AI-generated, especially when publishing educational or commercial content. Keep a neutral fallback voice so a missing provider voice does not block the entire episode. From there, the next practical step is render one audio file per turn. Rendering each turn separately creates a simple retry and editing boundary. The loop looks up the speaker's voice, sends the text-to-speech generation, and writes a numbered WAV file. WAV is convenient for editing because it avoids repeated lossy compression during intermediate processing. Existing segment files can be skipped, so an interrupted run resumes without regenerating completed speech. A manifest records the turn number, speaker, text hash, voice, and output path. Rate limit and network failures should use bounded retries with backoff rather than an endless loop. The terminal should show progress clearly without printing private document text or API credentials. This sets up the next important point: mix pauses and export the podcast. The mixer loads segments in numeric order so file system sorting cannot scramble the conversation. A short pause is inserted between normal turns and a slightly longer pause between sections. Each segment is normalized to the same frame rate and channel count before concatenation. PyDub assembles the timeline, while FFmpeg handles MP3 export. The final file receives a gentle fade-in and fade-out instead of abrupt edges. Export a transcript beside the MP3 so viewers can search the content and verify sources. The expected result is one playable episode plus reusable script, insight, and manifest files. The expected result is one playable episode plus reusable script, insight, and manifest files. That sets up run the complete pipeline. The command line interface exposes separate stages: extract, insights, script, render, and mix. Running all executes them in order, but individual commands are better while developing. The first run stops after script generation so you can review and approve the dialogue. After approval, the render and mix stages create audio without repeating document analysis. A successful terminal run reports extracted pages, insight count, script turns, rendered segments, and final duration. This stage-based design gives you control over cost, retries, and quality at every boundary. With run the complete pipeline in mind, the next piece is what the finished demo should prove. Start with a small, text-based PDF that you have permission to process. Confirm that the inside cite real pages and that unsupported questions are absent from the script. Listen for distinct speaker identities, consistent volume, reasonable pauses, and correct turn order. Change one line in the JSON, re-render only that segment, and rebuild the MP3. Then swap one voice or add a fourth speaker without changing extraction or insight code. Those two edits prove the architecture is modular rather than a one-use automation trick. That idea leads directly to common failures and practical fixes. If extraction returns almost nothing, the PDF probably needs OCR or may restrict text extraction. If the script invents facts, inspect the insight JSON and tighten the evidence-only prompts before changing voices. If dialogue feels repetitive, make speaker roles more distinct and reduce the requested number of turns. If a speech request is rejected, split long turns and confirm the configured voice and model are available. If MP3 export fails, verify that FFmpeg is installed and visible on the system path. If voices sound uneven, normalize segment loudness and avoid extreme delivery instructions. If reruns become expensive, cache by a hash of the text, voice, model, and instructions. Once common failures and practical fixes is clear, cost, privacy, and copyright boundaries becomes much easier to understand. API-based generation sends source text and dialogue to external services, so do not use confidential material without approval. Estimate cost before rendering by counting script characters and checking the provider's current pricing. Copyright permission to possess a document does not automatically grant the right to publish a derivative podcast. Keep source attribution in the transcript and distinguish source claims from your own commentary. Do not present synthetic voices as real hosts, and do not use voices designed to imitate identifiable people without consent. For sensitive workflows, replace hosted stages with approved local models and local TTS, then test quality and hardware requirements. The safe default is a licensed source, transparent AI disclosure, fictional speaker identities, and human review before publication. That idea leads directly to from prototype to reliable product. The prototype gives you an editable PDF to podcast pipeline with 3 speakers and resumable audio generation. Production improvements include OCR, token-aware chunking, citation verification, moderation, and a web-based script editor. Add provider adapters so the language model and TTS engine can be changed without rewriting the pipeline. Add automated tests for schema validity, speaker coverage, citation presence, duration, and audio file integrity. Store run metadata so every published episode can be traced back to a source, prompt version, model, voice configuration, and approval. The central lesson is simple: separate evidence, writing, voice, and mixing so each part stays editable and accountable. Your next useful extension is a browser editor that previews one turn before rendering the full episode. To wrap up, here is the key takeaway. You now have a structured overview of Build Your Own NotebookLM Audio Overview in Python. Review the core ideas, connect them to examples, and revisit concepts like build an editable 3-host podcast. See the whole pipeline first, project setup and folder design when practicing. Subscribe to Easy Machine Learning Guide if you want to learn AI through simple explanations and real industry examples.